All right, here we go. Sketch the graph of y equals x squared and its reflection in the line y equals x. So, and then we have a few questions specifically about that, but let's get to those second. So first off, y equals x squared. So if x is 0, we get 0, 0. If x is 1, we end up with the point 1, 1. When it's 2, we're at 4, 4. Negative 1, it gives us 1, 1, and negative 2 gives us negative 2, negative 4. And I think I might have said 4, 4 a second ago. So that's 2, 4, 1, 1, 0, 0, negative 1, 1, and negative 2, 4. And could have very easily, I'm sure at this point, just sketched that graph right in. But I want to be explicit about the points because we're going to be reflecting it over the line y equals x. And just having these points um, to guide us is going to be something helpful, I think. So let's sketch y equals x. And as I sketch this, I'm realizing my graph's probably a little bit off, just because we can see a touch of blue right here, but these values should be on the other side of the line. So, for example, I plug in 1/2 right now. 1/2 squared is 1/4, which would be below the line y equals x. So now let's reflect it. And so remember that as you have the points, and actually let's write down some of these points here, um, on the original function of y equals x squared. So we're going to have negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Now as we reflect it over the line y equals x, we're going to end up with the xy coordinates of those just swapped, the x for y and y for x. So we're going to have 4, negative 2, 1, negative 1. That 0 should be 0, 0. Sorry about that. 0, 0, 1, 1, and sorry, 4, 2. 4, 2. So let's go ahead and plot those. 4, 2, there we are. 1, 1, 0, 0, 1, negative 1, and 4, negative 2. All right, and so it's a very similar shape. It's a parabola kind of turned on its side. It's opening to the right. And we now have our graph as it's been reflected over the y equals x line. So is this resulting graph a function? And hopefully you're looking at it and see rather quickly that no, this is no longer a function because it does not pass the vertical line test. If I plug in, for example, x equals 4, I don't know if I get two different outputs. I get y equals 2 and y equals negative 2. So our proposed equation for the line, and you may have seen this in the other videos, we're going to have x equals y squared, which if we solve for y, take the square root of each side, we get y equals plus or minus the square root of x. And because of this, it's not a function. We plug in one x value, but we're getting out two y values, in this case, both the positive and negative y values. So want to, as far as the notes are concerned, that part's done, but do want to talk about this just a little bit more in depth regarding inverses. So if we have, and I'm going to sketch a very similar line right now. Actually, let's go with black. If that's a hideous line, but we'll run with it. If I am graphing just the positive x values and 0 of that same parabola, so this is going to be y equals x squared, but only with the domain of x is greater than or equal to 0. Now if I reflect that across the line of y equals x, we're going to end up with just this half of the parabola, just the positive y values. And this one will work out for us. Notice that, and again, so it's our first graph was y equals x squared, but only with the domain of y values. Now, when we take the inverse, this time we will have an inverse, because we will have the equation x equals y squared, but still with that same domain of x is greater than or equal um, to 0. But as we solve for x, we'll have y is equal to the square root plus or minus the square root of x squared, but without the plus or minus here. Our y values are always going to be the positive here, just as our range back on the original function is going to be, similar to this. It'll be greater than or equal to 0, and our range here is that y is greater than or equal to 0. Now, notice that we also, oops, that shouldn't be a squared right there. Notice also that we aren't plugging in any negative x values, so we're not getting any imaginary numbers. That's kind of a built-in part of the domain. But more specifically, that if we're creating the inverse, so if we have, let's call the first one, instead of y, let's now switch this to f of x, and instead of calling this one here y, let's call this g of x. Notice that if I have g of f of x here, that now my function can operate just fine. Every x value I plug in will get, after I put it through first the f function and then that output back through the g function, I get back to my original number. We now have the inverse function by eliminating our negative x values. Now our result is in fact a function, and now we do have the inverse. All right. We'll keep on working with that and build that out and help to make that a little bit less confusing as we go on. But I hope that helped.